All right. Hello. Let's get rid of all that stuff. Let's pop over here so I can see what's going on. All right. Cool. So, got a list of integrals here for us to do. One thing I want to point out is, for tomorrow's session, there won't be any new lecture video for tomorrow because it's just we're not going to do any new topics, so to speak. Like we're just going to focus on like looking at an integral and saying, how do I decide between integration by parts, u substitution, or something else. Just kind of just want to do some more practice with doing all these different types of integrals. So there won't be any new lecture videos for tomorrow's session. All right. So let's go ahead and get this countdown out of here and get started here. Oops. Prob 1. All right. So we're going to start off pretty simple. X cosine 5x. Right? So again, remember when we're doing integration by parts here, what we want to do is, there's that acronym we have, LIATE, which, stands for logarithmic, inverse trig, algebraic, trig, exponential. Right? And you want to think of your function in here as sort of a product of those two things. And you want to pick u to be the one that shows up in that list first, and dv as everything else. So, u and dv. So u, in this case, we have an algebraic part, which is the x, and a trig part, which is the phi, or cosine 5x. So u is x, dv is cosine 5x, dx. Right? And then we just need to find du and v. The du is dx. Just differentiate both sides. And v is going to be 1/5 sine of 5x. Give me 1 second. All right, let's try that again without the sneezing. Right. So we have our u, we have our v, we have our du and our dv. Now we can set up integration by parts. This is u times v, so 1/5 x sine of 5x, minus the integral of v times du. Right? And then now what we're going to do is just integrate this. Second piece here. So 1/5 x sine of 5x minus, when we integrate this, we get 1/5. Integrate sine 5x, we get negative 1/5 cosine of 5x plus c. Right? And so if we want to just clean this up a little bit, and there we go. And that's that. All right, any questions here? Hopefully it's a nice straightforward warm-up. So go ahead and try out the second one, problem or part 2 of this. Whoa, that zoomed in like crazy. So go ahead and try the second one. This is 2x e to the 3x. This one will be pretty similar to the one we just did here. Try that out, and then we'll work through this one. All right. All right. So here's our year in dv. Let's go ahead and wrap this up. So we'd get 2/3 x e to the 3x minus the integral of v du, which is 2/3 e to the 3x. So this is 2/3 x e to the 3x minus 2/9 e to the 3x plus c. That's that. That will be our integral. All right, hopefully that's not too bad. All right, let's go ahead and look at problem 3 here. Problem 3, we're looking at the integral of x ln of 10x dx. All right, so again, we have our u and our dv here. Remember, we picked u to be the first thing in the list. This time, the first thing in our list is ln of 10x. And then dv has got to be x dx. So when we differentiate u, du is going to be just 1 over x dx. And integrate v or dv is going to give v being 1/2 x squared. Right, so do the usual business. This is u times v, 1/2 x squared, ln of 10x, minus the integral of v du. So 1/2 x squared times 1 over x dx. So that 1 over x cancels with the second power there. And so we have 1/2 x squared, ln of 10x, minus 1/2 integral of x dx. And so finishing this up here, right, so we get minus 1/4 x squared out of that integral plus c. About all there is to that one. Any questions at all there? Right, so let's look at another one here. We have integral of x secant squared x dx. Okay. So here, again, we just need to pick a u and a dv. And here we have an algebraic part here for x and a trig part with the secant squared. So x secant squared x dx. Right? And then so du is just dx. V, remember the integral of secant squared is tangent of x. So when we integrate this, we're going to get, u times v, so x tangent x, But then we have to integrate, or so minus the integral of v du, so we have to integrate tangent of x dx. Right, so here, you can split up tangent into sine over cosine and do u substitution if you don't remember the integral. But integral here will be x tangent x minus ln of secant of x plus c. All right. And there we go. So again, it's just using the setup here for integration by parts. Nothing, hopefully, terribly complicated here. All right. If we look at the next one, x to the 9th ln of x. If we look at this one, again, think of, what our different pieces are. We have an algebraic piece here with x to the 9th, and we have a logarithmic part here with ln of x. So, u is going to be ln x, dv is going to be x to the 9th dx. Because again, the logarithmic part shows up first in that acronym. Right? So, we differentiate u. Du is 1 over x dx. V, we need to integrate this, so we actually get 1 over 10 x to the 10. And then just go ahead and do this as usual, business as usual. Minus the integral of v du. So if we multiply v and du, we have 1 over 10 x to the 9th dx. Right, because 1 over x times x to the 10 brings us down to x to the 9th. And so, integrate here. Integrate this piece, 1 over 10 times another 1 over 10 x to the 10. Let's see. And then, if you like, you could simplify it a little bit. Like by just multiplying this out, if you so choose. Leaving it as this line above is also perfectly fine. Completely up to you. Right. So, how about this one? I know these are going kind of quick, but really they're not that bad. The procedure for integration by parts is, once you understand kind of what the formula is asking you to do, you just need to be able to pick your u and your dv properly. Once you're able to do that, it just becomes apply integration by parts. So the challenge in integration by parts is picking the u and the dv. All right. So let me write the next problem, and then I'll give you a bit to think about it. So think about that one, and then we'll go over it. All right. So let's look at what we have in this part right here. Again, we need a u and a dv. Right? So, this function here, you can think of it as, 1 over x to the 10. I shouldn't write that right here. This is kind of 1 over x to the 10 times ln x. So ln x is still our du, it's our logarithmic part. 1 over x to the 10 is an algebraic part, so that's our dv. So du is 1 over x dx. V is minus 1 over 9 x to the negative 9. Right, because this is x to the negative 10, and we just use the usual power rule on this. All right. So, do our usual thing here. Minus 1/9, x to the minus 9, ln of x. That's our u times v. Minus integral v du. So actually, that minus in this one can turn into a plus. 1 over 9. We have x to the negative 9 times 1 over x. So that's x to the minus 10 again. Negative x to the minus 9, ln x. Right. Let's see here. And then we integrate this. We're going to get our 1 over 9 and another minus 1 over 9, x to the minus 9, plus c. So minus 1 over 9, x to the minus 9, ln x, minus 1 over 81, x to the minus 9, plus c. All right, so hopefully that all looks good there. All right. Now this next one here, this is kind of interesting. X sine x, cosine x. How do we want to approach this one? Right. So this one here, we we need to split up into a u and a dv. And in this case, we're gonna apply the acronym as always. This is the algebraic part, the x. The sine times cosine, that's a trig part. U equals x. dv is sine x cosine x dx. Right? So du is just dx here. Right? To integrate this one here, technically you want to do a u substitution. U equals sine x, then du would be cosine x dx. So what that means is your integral here is actually this. 1/2 sine squared x. Right? So if you're a little unsure of that, go through the work of doing the u substitution integral. Or if you want a quicker way to check that this is right, just differentiate 1/2 sine squared of x. Right? So now we have to figure out how to integrate this. So we got 1/2 x sine squared x minus b du. So minus 1/2 integral sine squared of x. All right. So now there's a bit of trickiness going on here. How do we integrate sine squared? How do we do that? Well, we need to use a trick on it. Right? The trick for this, there's a trig identity here that says sine squared of x is equal to 1 minus cosine of 2x over 2. Right? We actually need to use this trig identity here. This is how we get through this one. So we get 1/2 x sine x squared minus, right, this over 2 here, I can factor out as another 1/2. So this turns into this. Okay. So we got that there. And now we want to integrate this. Now this we can actually integrate, right? There's nothing tricky going on here. We have 1/2 x sine square root of x minus 1/4. Integrate here, we have x minus 1/2 sine of 2x plus c. Right, and we can multiply out that 1/4. There's really not much point in doing it at that point, or at this point, so we'll leave it like this. All right. Any questions at all about that one? All right. So number 8 here. Number 8, I just want to start doing some definite integrals. Get a few of these in here for us. We got 0 to 1, x e to the minus x dx. Right? So something pretty straightforward. So just as always, we're going to do our u and our dv. In this case, u should be x, dv should be e to the minus x dx. Because algebraic comes before exponential. du is dx, v is negative e to the minus x. So we have our u times v minus x e to the minus x. And remember, the only real sort of distinction here with integration by parts is we just have to evaluate everything from 0 to 1. Right? So now we do minus integral of v du. I'm going to take this negative sign and factor it out to make this a plus. And again, this integral's from 0 to 1. Right? So, form this. I'm going to leave this part as is. I'm not going to evaluate this yet. You can do it right now if you want. I quite like doing it afterward. Here, so I want to integrate this. This is negative e to the minus x from 0 to 1. So here we're kind of now saying, all right, we can just evaluate all this stuff at once from 0 to 1. Right? And I personally think this is a little bit nicer, but at the end of the day, do whatever you want, All right. So plug in 1. So we're going to get negative e to the minus 1 minus e to the minus 1. And then plug in 0, 0 minus e to the 0. So this first part is negative 2 e to the minus 1. This part becomes plus 1. Right? And you can simplify that if you want by changing the negative exponents to positive, by putting it in the denominator. You can give it a common denominator if you want between the two parts. It's really up to you. There's not much reason to do it. Sitting right here with this is good enough, really. All right, any questions about that one? I know we've kind of just blazed through 8 examples out of the 11 already, but hopefully we're all good here. All right. So let's look at problem 9. All right, problem 9, we're integrating from 1 to e squared of x squared ln x. So go ahead and try this one out on your own here. And then we'll go from there. Right, so give that one a try. All right. So let's see how we did. Right, so again, this has a logarithmic and an algebraic part. So u is going to be the ln. dv is going to be the x squared dx. So du is going to be 1 over x dx. v is going to be 1/3 x cubed. So u times v, 1/3 x cubed ln x, from 1 to e squared, minus the integral of v du. So integral from 1 to e squared of v du is 1/3 x squared dx. dx there. All right. So now that we have that, just integrate this piece. So 1/3 x cubed ln x. Now, since these are both going to be evaluated between the same things, let me just sort of skip separating them. Integrate this, and we're going to get minus 1/9 x cubed. This is from 1 to e squared. All right. And now just plug all our stuff in and see where we end up. All right. So plug in the e squared. We're going to have 1/3 e squared cubed is e to the 6th. ln of e squared. Actually, all right, so let me actually do this. And then minus 1/9 e squared cubed. Okay. So that's plugging in e squared. Now let's plug in 1. 1/3, 1 cubed is 1. ln of 1. Minus 1/9, 1 cubed is 1. ln of 1 is 0, so this part's just gone, which is nice. All right. So here we have 1/3 e to the 6th. Now ln of e squared, this is going to be 2, because remember the ln and the e cancel out. So this is times 2. Here we have minus 1/9 e to the 6th. And then here we just have plus 1/9. So if we want to simplify this, here we're going to have, this is 2/3 minus 1/9 e to the 6th. Both of these have an e to the 6th in it. Plus 1/9. And so let's see. This is 6/9 minus 1/9. We got 5/9 e to the 6th plus 1/9. So it's possible to simplify that, of course, but not a big reason to. Right. So how are we doing here? That'll work out. Any questions about this one? All right, cool. There's no questions. Let's go on to the next one. 10. We're looking here at the integral from 1 to 2, e to the 1 over x squared dx. So think about this one. All right. So what are we doing here? If you look at this one carefully, you don't need integration by parts. Wanted to sneak one of these in. So here, if we make u to be 1 over x, then du is going to be minus 1 over x squared dx. So this integral is e to the u times minus du. Right? So plug in 1 to the bottom here, you get 1. Plug in 2 to this, we get 1/2. Okay? So this is just a u sub problem. Wanted to make sure you didn't forget about u sub. So here, we integrate this, we're going to have minus e to the u from 1 to 1/2. So that's negative e to the 1/2 plus e. Right? So the reason I put this in here is I want to point out it's not always the best to just blindly apply integration by parts to everything you see. So look carefully at your problem. There might be no reason to do integration by parts at all. Okay? Just keep that in mind. All right. So let's go ahead and set up for the last problem here. Last problem here says the integral from 0 to 1 of arc sine of x dx. Right? So this one is going to require actually being able to integrate arc sine. And remember how we have to do that. So this, we did arctangent, and logarithm actually is done the same way. We did these in the lecture videos. So here, we find u is arc sine x, right? Because you can think of this thing we're integrating as arc sine of x times 1. Right? So if we think about it that way, then dv is just dx. Right? So when we differentiate du, we're going to get 1 over square root 1 minus x squared dx. If we integrate v is just going to be x. Right? So v times u, or u times v, x arc sine x from 0 to 1, minus the integral from 0 to 1 of v times du. All right, and now that we're here, we have to do a u substitution on this integral. All right, so we need to do u is 1 minus x squared. If you want, maybe we should do this. Since I already used u and v here, maybe it couldn't hurt to use w, something different. But, I mean, you can use u again. It doesn't really matter. The dw is going to be minus 2x dx. Now, in this case, you know, let's write this real quick here, 0 to 1. These bounds are going to change, right? So here we're going to have, this is going to end up being w to the minus 1/2, minus 1/2 dw. The bounds here are different, right? We plug in the 0 here, and we get 1. Plug in the 1 here, and we get 0. So just keep that in mind. The bounds are different. Now, in this case, it's kind of a coincidence as these two are just the same but flipped over. But there's no reason this has to be the same numbers as this. So, you know, if you have to do a u sub in your integral here, it might be better to just sort of evaluate them separately. Anyway, so x arcsine of x from 0 to 1. Here, we're going to get, when we integrate this, this will be, let's see, negative w to the 1/2 from 1 to 0 when we integrate this. Okay. And now we just go about our business here, plug some stuff in. Here we're going to have arcsine of 1 minus 0. Just plug in the 0 here, we get 0. Okay, and then here, this minus and this minus make a plus. Plug in 0. Minus 1 to the 1/2 is square root of 1. So we get this. All right, arcsine of 1. So we're saying sine of what value is equal to 1? That's pi over 2. And then plus negative 1. And there we are. All right. All right. So that is this integral. Any questions about that one at all? Or any of the 11 we did here? Awesome. Yeah. Great to hear they make sense. Yeah, these integration by parts, like I was saying, is just, it's pretty straightforward once you sort of see what's going on in the problem. So in that case then, I think we'll stop here. And then tomorrow we'll do, you know, we'll kind of mix up a bunch of integrals and say, you know, here's some that you might be able to do just directly. Here's some where you might want to, you know, do u substitution, integration by parts, just to start getting a different feel for them. So like I said, there'll be no new video or lecture set for tomorrow. We're just going to sort of do practice on these. All right. Well, with that, if there's no questions, then have a good afternoon. And I'll see you guys next time.